Hi, this is Dr. Hall. We're looking today at more electrolysis, this time of aqueous solutions. We'd previously been looking at electrolyzing molten compounds. When you do that, there are only a couple of ions to consider, whereas when we do aqueous solutions, there are some more ions that can come into play. So it's a little bit more complicated. To get us started, there's this activity. If you could just pause the video and think about what the labels are going to be, where those labels fit in on this diagram. And you should have been able to spot that the battery or cell is up here at the top. Get my pointer going. The battery or cell is here, connected by wires to these electrodes. We don't know which way around that battery is, so this could be either the anode or the cathode, and whichever one that is, this is the other one, so it's the other way around. And the electrolyte is what the electrodes are dipping into and what is being electrolyzed. So today we're looking, as I say, at aqueous solutions. What happens to ions during electrolysis? How does water affect what is produced? And how can we represent reactions that are happening at each electrode using what are called half equations? So we'll start with just remembering positive ions are going to be attracted to the negative electrode. Opposites attract. So they'll be moving towards the cathode, and there they gain electrons, and then they turn into metal atoms. Whereas negative ions would move towards the positive electrode, that's the anode, and there they give up their electrons and become molecules. So half equations describe what happens at one of those particular electrodes. We might have copper, for instance, being attracted to the cathode, copper-2 ions, and the half equation for that reaction looks like this. We've got copper-2 ions picking up some electrons to make copper atoms. And notice the charge on the copper is 2+, so it needs to pick up 2 electrons in order to become electrically neutral and form those copper atoms. At the anode, we'll be attracting here some chloride ions, Cl-. They're going to give up electrons and make chlorine gas. So chlorine gas is Cl2, so we need 2 chloride ions in order to do that. And in order to balance this equation, make it electrically neutral, we now need 2 electrons on this side of the equation. So here's a little animation of electrolysis happening in molten copper chloride. So we've just got 2 ions here, the copper-2+ ion and the chloride Cl- ion. I've drawn a little circuit here. We've got a negative electrode, the cathode on this side, the positive electrode over here. So when that current is turned on, the positive ions are attracted towards the negative electrode. So the copper ones move over there, and the chloride ions are attracted to the positive electrode. So they will start to move towards that anode. So let's look in a bit more detail at what happens at each electrode. Here we've got the copper 2+ ions have been attracted to the cathode. They're going to pick up some electrons, 2 electrons, and turn into copper atoms like that. So they pick up electrons and make copper metal. There's the half equation for that, as we've seen it before. And that copper metal is actually going to be deposited onto the cathode. Over here at the anode, we have the chloride ions, and those are going to be giving up electrons and turning to chlorine gas, which forms bubbles. Bubbles will go up around the electrode, and they've surrendered some electrons. And again, there's the half equation, chloride ions making chlorine gas and giving up electrons. So what happens if we have an aqueous solution? We've got water molecules present, and they can have an impact on what is produced, because water will split up to a certain extent into these two ions. It makes a hydrogen ion, H+, and a hydroxide ion, OH-. So those ions are going to be present in the water. They will also be attracted to the electrodes. But we'll find that only one positive ion and only one negative ion will be discharged at each electrode. They're in competition. And what happens is, if two elements could be produced, the one that is less reactive is the one that usually will be formed. So if, for instance, we've got, let's say, sodium ions as well as hydrogen ions in our solution, we could in principle form either sodium or hydrogen at the cathode. So hydrogen is much less reactive than sodium, so it's the hydrogen gas that is formed at the cathode, and the sodium ions just remain in the solution. So when we've got sodium and hydrogen ions, hydrogen gas is the one that is formed. That's the least reactive. But if we had, let's say, copper 2+ ions and hydrogen, in principle, either hydrogen or copper could be formed at the cathode. The less reactive one is now the copper. So in that case, copper would be produced at the cathode, the copper metal would be deposited there, and the hydrogen ions remain in solution. No hydrogen gas is produced. We've also got to think about the negative ions. So that might include OH- from an aqueous solution of water. When those ions are discharged at an electrode, this is the reaction that we see going on. We've got, it looks quite complicated, but mostly that's to balance this equation. Oxygen is the gas that is going to be produced, so we need O2 there. So we have to start out with 4 hydroxide ions. They're going to give us 2 H2Os, which is just creating more water, and oxygen gas, and they're giving up their 4 electrons. So this is quite a common reaction to see in electrolysis of aqueous solutions. Oxygen gas is produced. So that will tend to happen unless we have some halide ions present, something like chloride or bromide, because those will tend to produce the halogen instead of oxygen. So when we're looking at negative ions, if we have some halide, that will be most likely to be produced to produce a halogen. Next comes hydroxide, and after that all the other negative ions. And typically in GCSE we'll be looking at halides and hydroxides being discharged. So how can we represent the reactions using half equations? Well, we've seen some of those as we've been going along. So here is copper forming at the cathode. If we were to write a half equation for that, Cu2+, it's picking up electrons and forming copper. Chlorine forming at the anode. Here we're losing electrons. We're forming Cl2. Don't forget the 2. Chlorine gas is a diatomic molecule. So here we need 2 chloride ions in order to balance the equation. And we'll notice here that the charge balances in these equations as well as the number of atoms. So we have 2 chlorines on this side, 2 chlorines on this side, 2 negative charges here, 2 negative charges here. If we've got water present, we might have hydrogen forming at the cathode. So here we have 2H+, picking up electrons to make H2 gas. And then the other equation which we've just seen, 4OH- giving O2, 2H2O, and 4 electrons. Here's an exam question in this area. So we're thinking about electrolysis of molten zinc chloride followed by potassium bromide solution. That will be a solution in water. Complete the table below to predict the products. So you have to choose answers from this box. And you've got the two substances, and you have to say what's produced at the cathode, anode, for each of those two things. So have a go at that, pause the video, draw that table in your books, and see if you can get the answers before we look at the next slide. So here are the answers. In the case of molten zinc chloride, we've only got the two ions Zn2 plus and Cl minus. So Zn2 plus is going to be attracted to the negative electrode and be converted there to zinc. At the positive electrode, we're going to attract chloride ions, Cl minus, and they'll be converted there to chlorine. In the potassium bromide solution, we don't get potassium produced at the cathode, we get hydrogen formed from the H+. Hydrogen is much less reactive than potassium. So remember, the least reactive element is what is generated. Over at the anode, we have two possibilities, oxygen or bromine. And remember that the order of reactivity there is that the halides are produced in preference to oxygen, in preference to any other negative ion. So when we have a halide solution, we're going to be producing halides. So the halogen here is bromine. Bromine is formed at the anode. Okay, I hope that's been useful. I'll put this PowerPoint as well as the video into the lesson. Hope you enjoy it.